Our solar system is a vast and mysterious place. Past the gas giants lies a frigid and dimly lit region known as the Kuiper Belt. This distant realm is a cosmic graveyard filled with icy remnants from the early solar system. The Kuiper Belt is a donut-shaped ring starting at about 30 astronomical units from the Sun. It extends outwards to approximately 50 astronomical units. This region is teeming with icy objects ranging in size from small pebbles to dwarf planets larger than Pluto. The Kuiper Belt is named after Gerard Kuiper, a Dutch-American astronomer who proposed its existence in 1951. But it wasn't until 1992 that astronomers discovered the first Kuiper Belt object. Since then, we've identified thousands of these objects. Scientists believe there may be millions more. The Kuiper Belt is a fascinating and important region of our solar system. By studying it, we can learn more about the formation and evolution of our planetary system. We can also gain insights into the conditions that existed in the early solar system, billions of years ago. This knowledge helps us understand the building blocks of planets. The Kuiper Belt is a key to unlocking the secrets of our cosmic neighborhood. The Kuiper Belt is often compared to the asteroid belt. While there are some similarities, there are also key differences between these two cosmic neighborhoods. The asteroid belt lies between Mars and Jupiter, much closer to the Sun than the Kuiper Belt. The asteroid belt is composed mainly of rocky and metallic objects, leftovers from the formation of the inner planets. The Kuiper Belt, on the other hand, is much farther out and much colder. Its inhabitants are primarily made up of ices, including water ice, frozen methane, ammonia, and other volatile compounds. Another difference is size. The asteroid belt is relatively small and densely packed. The Kuiper Belt is much larger and more dispersed. It's estimated to be 20 times as wide, and 20 to 200 times as massive as the asteroid belt. While both belts are fascinating remnants of the early solar system, their distinct compositions, locations, and sizes provide valuable insights into the diverse processes that shaped our planetary neighborhood. These differences highlight the complexity and variety within our solar system. The Kuiper Belt is home to a diverse collection of icy worlds. Some of these are large enough to be classified as dwarf planets. The most famous of these is Pluto, which was once considered our solar system's ninth planet. Pluto, discovered in 1930, was long thought to be a solitary world in the outer solar system. However, the discovery of the Kuiper Belt revealed that it is just one of many similar objects in this distant region. Eris is another notable dwarf planet in the Kuiper Belt. Discovered in 2005, Eris is slightly larger than Pluto and has a highly eccentric orbit. Haumea, discovered in 2004, is a bizarre, rapidly rotating dwarf planet, shaped like a flattened football. It has 2 moons and a ring system, making it a unique and intriguing object for further study. Makemake, discovered in 2005, is another large dwarf planet in the Kuiper Belt. These are just a few of the many fascinating and diverse objects that call the Kuiper Belt home. Each of these worlds holds clues to the early solar system and the processes that shaped our cosmic neighborhood. The Kuiper Belt isn't just a collection of icy rocks. It's a cosmic time capsule from the early days of our solar system. These objects are remnants from the protoplanetary disk around the young Sun. They have remained unchanged for billions of years due to the cold and distance. Studying their composition and orbits reveals the processes that formed the planets. The distribution of objects provides clues about the early solar system. The scattered disk suggests giant planets migrated, scattering objects. These pristine icy objects offer a window into the early solar system's chemistry. Analyzing their composition gives insights into the building blocks of planets. In 2006, NASA launched the New Horizons spacecraft to explore Pluto and the Kuiper Belt. After a 9-year journey, New Horizons made history in July 2015 by flying past Pluto, sending back stunning images and data. It revealed Pluto to be a complex and diverse world. Pluto has a thin atmosphere, nitrogen glaciers, water ice mountains, and a heart-shaped plain. The mission also provided insights into Pluto's moons, especially Charon. After Pluto, New Horizons journeyed deeper into the Kuiper Belt. In 2019, it flew past Arrokoth, the most distant object ever visited by a spacecraft. The data provided an unprecedented look at a remnant of the early solar system. New Horizons has expanded our knowledge of the Kuiper Belt, challenging previous assumptions and opening new research avenues. The discovery of the Kuiper Belt has led to speculation about the possibility of undiscovered planets lurking in the outer reaches of our solar system. Some astronomers believe that the gravitational influence of a large unseen planet, often referred to as Planet 9, could explain the unusual orbital patterns of some Kuiper Belt objects. These objects, known as extreme trans-Neptunian objects or ETNOs, have highly elongated orbits that cluster together in a way that suggests they are being shepherded by the gravity of a massive object. While Planet 9 remains hypothetical, the search for this elusive world continues. If Planet 9 exists, it is estimated to be several times more massive than Earth and located hundreds of astronomical units from the Sun. Its discovery would have profound implications for our understanding of planetary formation and the history of our solar system. The potential for undiscovered planets in the outer solar system highlights the vastness and mystery of our cosmic neighborhood. The Kuiper Belt is not only a repository of ancient icy objects but also a breeding ground for comets. Comets are icy bodies that release gas and dust when they approach the Sun, creating the characteristic tails that streak across the sky. Short-period comets, those with orbital periods of less than 200 years, are thought to originate in the Kuiper Belt. These comets are nudged into orbits that bring them closer to the Sun by the gravitational influence of the giant planets, particularly Neptune. As comets approach the Sun, they heat up, and the ices on their surfaces sublimate, releasing gas and dust that form the comet's coma and tail. Studying comets provides scientists with valuable information about the composition of the early solar system, as comets are thought to be pristine remnants of the material that formed the planets. The Kuiper Belt's role as a source of comets highlights the interconnectedness of our solar system, sending these icy messengers on journeys that bring them close to Earth, providing us with spectacular celestial displays and valuable scientific insights. The James Webb Space Telescope, launched in December 2021, is the most powerful space telescope ever built. Its advanced capabilities are providing astronomers with an unprecedented view of the universe, including the distant and enigmatic Kuiper Belt. JWST's infrared sensitivity allows it to see through the dust and gas that obscure our view of the Kuiper Belt in visible light. This allows astronomers to study the composition and surface features of Kuiper Belt objects in greater detail than ever before. JWST's observations are helping scientists to characterize the composition of Kuiper Belt objects, search for evidence of past collisions, and study the dynamics of this distant region. JWST's observations of the Kuiper Belt are providing new insights into the formation and evolution of our solar system. Its powerful capabilities are helping to unravel the mysteries of this distant and enigmatic region, revealing the secrets of our cosmic neighborhood. While we have learned a great deal about the Kuiper Belt in recent decades, many mysteries remain. Future exploration is essential to deepening our understanding of this distant and enigmatic region. One of the biggest unanswered questions is the origin of the Kuiper Belt itself. How did this vast ring of icy objects form, and what role did it play in the evolution of the solar system? Future missions to the Kuiper Belt could include dedicated spacecraft that would fly past, orbit, or even land on these distant worlds. These missions could provide detailed information about the composition, geology, and history of Kuiper Belt objects, helping to answer some of the many questions that remain. The study of the Kuiper Belt is not merely an academic pursuit. It has profound implications for our understanding of our place in the cosmos. By exploring this distant region, we are gaining a deeper appreciation for the diversity and complexity of planetary systems. The Kuiper Belt reminds us that our solar system is not a static and unchanging place. It is a dynamic and evolving system shaped by the gravitational interactions of its many constituents. The discovery of the Kuiper Belt has challenged our assumptions about the architecture of planetary systems. It has shown us that planetary systems can be far more complex and diverse than we once imagined. By studying the Kuiper Belt, we are not only unraveling the history of our solar system, but also gaining a deeper understanding of the conditions that led to the emergence of life itself. This knowledge can help guide our search for life beyond Earth, as we explore other planetary systems in our galaxy. The Kuiper Belt is a vast and mysterious realm that holds many secrets waiting to be unlocked, promising new and exciting discoveries that will further revolutionize our understanding of the solar system and our place in the cosmos.